In this video, we're going to cover working with complex numbers. This is section 7.7 in our intermediate algebra. So we're going to be able to recognize a complex number, add and subtract complex numbers, multiply them, divide them, and then find powers of I. Okay, so these are the learning goals that we're going to cover. So starting out, let's review a little bit. So we have 5 minus square root 7. So we're going to have to rationalize this. Remember, we have to rationalize this with a conjugate. So we have to do 5 plus square root 7 on the bottom and on the top. So multiply 5 times 5, that's 25. 5 times square root 7, that's plus 5 root 7. And then we have a minus 5 root 7. And then we have negative root 7 times positive root 7. So that would just be a negative 7. And in the top, we have 3 times 5 and 3 times root 7. So that would be 15 plus 3 root 7 in the top. Okay, so then we simplify things down. Those are going to cancel out. In the top, that 15 plus 3 root 7. And then the bottom, we have 25 right there, minus 7. That is an 18. Now we look to see if we can take something out of all three of these. So I could take a 3 out, so that'd make that a 5. That 3 is gone. That makes that a 6. So 5 plus square root 7 over 6. And there we have that. For B, we're solving a radical equation. So remember, first step is to get this by itself. So add 9. And then we got that radical on the left, square root 5x plus 1. We got a 9 on the right. And now we have to square both sides if we want to get rid of that radical. Okay, so that's going to take care of that. 5x plus 1 on the left and 81 on the right. And now we just work to simplify like normal. So 5x on the left, we move that one over, and we have an 80 on the right. And then divide both sides by 5, and we get x equals 16. And we can double check that if we want to. So you would check that by plugging that back in there. Okay? So looking at the new stuff for today. So recognizing what a complex number is important. Okay? So really what we're working with here is square roots of negatives. Okay? We call that the imaginary unit I. Okay? Or complex. All right, so if we have a square root of a negative, that is going to give us an I. So if we're looking at this example here, we have square root of negative n. So that will be like a negative 1, kind of like that. And so we can kind of use our product property, split those, and that negative 1 turns into an I. Okay, so easy way here, if you have a negative in there, in a square root, just bring that out front as an I, and then you would have the complex with the radical. Okay, so similar here, I'll show you how this works, turns into that. So that negative underneath there, I can't simplify this unless I bring that negative out as an I. So this would be I root 81, and root 81 is a 9, and you just put the I behind the 9. Okay, so that's how those work. So I's come out first, then simplify the radical like normal. Okay, so let's look at this one. So I got a negative underneath there. That comes out. So I have I root 4, and the root 4 is the 2. So this would be 2I. Okay, same thing here with the 49. That negative comes out. I root 49, and then square root 49 is a 7, so this turns into 7I. Okay, what do we do if it's not perfect? Well, we still have that. So that brings the I out, and then we break down this as a factor tree. Okay, so now we're just treating this like a normal radical where we factor it out, and we're looking for 2 of a number. So the 5s will give me a 5 in front. That goes with the I, and then that 2 goes back underneath. Okay, same thing here. Take the negative out, then break down the 24. And then we look for groups of numbers. So I have a group of 2s, and then those have to go back. So 2 would come out, I have the I in front, and then the 2 and the 3 go back as a 6. And then we have it simplified. Okay, so since we're talking about these new kinds of numbers, these complex numbers, there's a general form or a specific way that we got to write them. Okay, there's a real part, that'll just be the regular number, a real number, and there's a complex or imaginary part. This would be B, it would be a number, possibly 1 in front of the I. Okay, so if we had something like 3 plus 2I, this would be the way to write this. I cannot write 2I plus 3. I can't write that way. So I have to have specific order when I write these out. The complex part is always last, okay? And that's important for everything that has a real number and a complex number because the order is important, okay? So looking at these ones down here, what we have to do first is simplify them. So remember, if I get a negative, that comes out in front of an I. And then we simplify this part just like normal. Okay, so this would be 7 plus square root of 36 is a 6, and then we have an I, okay? And I have to write the I last. If I had that switched around, that would be incorrect, all right? Same thing over here. We bring this out in front, so negative 4 minus I root 12, and then we have to break down the 12, 2 and 6, 2 and 3, so we got a pair of 2's, okay? So it'd be negative 4 minus 2I root 3. That's how we write that, okay? The I is always directly next to the radical, and if you have a number that comes out of the radical there, that would go in front of the I like that. Okay, if you have like variables and stuff like that, those would come before the I as well. I is always directly next to the radical, okay? So, to add and subtract complex numbers, you have to pay attention to the variable, or not the variable, the I, okay? We're going to treat the I like a variable, okay? And these look similar to FOIL. We're not foiling though. We're doing this stuff plus this stuff, okay? They're written with parentheses, so that way you can see that I have this complex number added to this complex number, okay? So what we do is add the real part, so 8 plus the negative 12 is a negative 4. Add the complex part, 7I plus 11I plus a positive 11I. So 7 plus 11 is 18, so we have 18I. We do it like that. So it's just kind of like terms. Add the real numbers, add the complex numbers, okay? So same thing here. We have this complex number. Now we have a minus this complex number. So what does a negative do to everything to the right of it? All right, that needs to go into this one. So you might want to rewrite this one before you do anything. So that would make that a positive 6, and that would make that a positive 2I. And now I'm looking to combine like terms here. 9 plus 6, 15. 15 plus 2 is 17I. That's the complex part, okay? And again, make sure we write it like this. A plus BI. I must have the I last in order for it to be in standard form or general form, okay? So multiplication, this is where it starts to get a little tricky, okay, because we have to remember rules of multiplication. The first two here are pretty easy, okay? So square root of negative 1, that's just I in general. Remember, a negative underneath a radical is just I. So if I did this, it'd be I root 1, and root 1 is just a 1, so really this is just I, okay? So square root negative 1 is just an I squared, okay, up here it tells us that I squared is negative 1, and let me show you why. Okay, so negative 1 times negative 1, a property of radicals is if you're multiplying the same exact radical, then the radical just cancels out. So this is really like square root of negative 1 squared. That radical cancels with that, and then you have a negative 1. So I squared is equal to negative 1, okay? This is probably the most important one of these four that I'm going to go through. All right, this one, and then I to the fourth as well. So I to the third, how does this work? Well, we're really taking this, negative 1, and multiplying it by an I, okay? Because that would be I times I squared is equal to I to the third, okay? So this is just a negative I. And then over here, I to the fourth, okay? I'm going to relate this back to I squared. I to the fourth is I squared times I squared, which is negative 1 times negative 1. Well, what's a negative 1 times a negative 1? That's a positive 1, okay? So this and this are the most important ones. We're probably going to use this one more often, okay? So since I showed you how to multiply i's together, we're looking at how to multiply complex numbers, okay? So you need to change all imaginary numbers to BI form. That means simplify them if you can, because you cannot do any of the multiplication properties unless you have simplified them, okay? Then multiply them as if you were just to multiply polynomials. And then this is very important. Substitute negative 1 for each I squared. So wherever you see an I squared, always switch it to a negative 1. And I'll show you what I mean here on these examples. And then the last one, combine like terms, and you are done. Okay? So this one is already simplified into the BI form, right? The i's are out. There's no square roots of negatives. So I'm going to multiply the numbers in front. I would multiply these as if this were an x, okay? So this would be negative 21i squared, okay? Now, the thing with these is I cannot just leave that I squared, all right? I squared substitutes to a negative 1. So what this is now is negative 21 times a negative 1, which flips to a positive 21, okay? So the way I like to do this, whenever I see an I squared like this one right here, I'll slash that, change my sign, and I'm done. So I got that positive 21, okay? That's the easiest way. If you remember I squared negative 1, just get rid of the I squared, flip all the signs, and you are done, all right? So these are the ones that you have to change to BI form before you're allowed to do anything, okay? So that essentially means fix the negative into the square roots. So this would be I root 3 times I root 12, all right? And then we have to remember how we multiply something like this and something like that. Well, you multiply the stuff out in front, I squared, then you multiply the stuff underneath, 36. So 12 times 3 is 36. And now we have to keep simplifying. So 36, this is just a 6. I squared, well, that flips to a negative 1, so this is a negative 6. That's what we end up getting there. So the important piece here, what a lot of people like to do, a lot of people like to leave this and just multiply it, and then you got square root 36. But if you look at the end here, that's not the right answer. It should be, well, square root of 36 is a 6, but we should have the opposite of that, okay? So you'd be missing the piece here where we have to change it to the specific form before multiplying, okay? So distributing, so I would like you to try these before you watch this. You distribute it just like an x, but then you have to remember how to simplify it in the end. So if you want to pause the video, work through these, and then come back, that would be great. All right, so multiplying things through. So this one, the 5i is going through here. So 5 times 6, that's 30i. 5 times 2, that's minus 10i squared. Then we got to remember, what can we simplify? Well, I see an I squared there. Cross that off because it switches to a negative 1, and then you flip the sign of that number that it's attached to. And then we have 30i plus 10. That's not done because we have to flip-flop these around because it's got to be a plus bi. So 10 plus 30i. That is the correct answer. Okay? For b, we're foiling. 4 times 6 is 24. 4 times 5i, that's a minus 20i. Negative 2i times 6, that's a negative 12i. And then a negative times a negative, that's a positive 10i squared. Okay? Do you see an I squared? Yes, I just said that one right there. I squared is going to flip this to a negative 10. Okay? So now we combine like terms. So 24 minus 10, it's beneficial to do the real part first, so you don't have to switch things around. So 24 minus 10 is 14. And then negative 20i minus 12i is negative 32i. So we have 14 minus 32i. Okay? Big thing here, remember how to FOIL, and then change that I squared into a negative 1, add like terms, and then you're done. Okay, so C, similar, we're just FOILing. So 3 times 3 is 9. 3 times the negative 2i is negative 6i. 2i times 3 is a positive 6i. And then 2i times negative 2i is negative 4i squared. Okay? I squared right here, flips that, and then we add like terms. Those are going to cancel because they're opposites, so we have a 9 plus a 4. That's going to be a 13. Okay? And D. So again, what you might want to do is you might want to start doing that, but we can't do that. What do you need to do first? Because the negatives are underneath there. You got to change it to BI form. I got to bring the I out, okay? And this is actually going to be a nice perfect square. So this is 3i, and then this one is I root 3 plus 8. Now we are allowed to do the rules where we can multiply things. Okay, so this looks a little goofy for the first one. I'm multiplying this by this. Remember, multiply the stuff on the outside, and then if there's anything on the inside, multiply that. So this first number is 3i squared root 3, and then I go into the second number. So 3 times 8 is a 24i. And then simplify if we can, which we can simplify this right there. I squared turns to a negative, and then we have this number here. So negative 3 root 3 plus 24i. So yes, you can have a square root and an I in the same question. Okay, so going on to the next concept here, when we're dividing complex numbers, you have to remember this word here, complex conjugates. So conjugate is the word you should remember. So if we have something like this, then the conjugate is 3 minus root 2. Same numbers, opposite sign in the middle. Okay? Same thing with complex numbers. 3 and a 7, 3 and a 7, opposite signs in the middle. All right? So we're going to use complex conjugates to simplify when you have division of complex numbers. Okay? So you need to look at the bottom. Okay? So the bottom of the fraction. If I'm looking at the bottom of the fraction right there, I don't have plus or minus anything, so I don't have to worry about conjugates. These are actually easier, okay? So what can we multiply by to simplify this? Well, it's kind of like a square root. This is a square root of negative 1. So remember, square roots, you just have to multiply by the same square root. So in this case, I just multiply top and bottom by an I, all right? So if I think about what number this is, I over I, that's just a fancy 1, right? I over I cancels to a 1. So I have to distribute in the numerator, and I just multiply in the bottom. So I will have 9i plus I squared in the top, and in the bottom, I have an I squared. So then remember, I squareds, what do they turn into? That's a negative 1. That's a negative 1. Okay? I'm just going to rewrite this stuff. So on top, I have 9i minus 1, but we want to flip that around. Negative 1 plus 9i over negative 1. And we don't ever want to leave a negative in the bottom. So remember from a previous lesson, negative 1 in the bottom will flip everything in the top. So that'll flip to a positive, that'll flip to a positive, and this will flip to a negative. And then I just rewrite it out. So 1 minus 9i. Okay? So B, give it a try, and then come back to it. All right, so I have a single I in the bottom. So what I need to do is multiply by another I in top and bottom. The top distributes, 3i minus I squared. The bottom just multiplies, I squared. And then we flip them all. So negative 1 on the bottom. That flips to a positive 1. So in the numerator, I'll have 3i plus 1 over negative 1. And then here we can just flip the negatives. So this will turn to a positive, that'll turn to a negative, and this will turn to a negative. And we rewrite it in standard form. So negative 1 minus 3i. Okay? You have to write it in standard form, otherwise it's not correct. Okay? So a couple more here with division. So now, if I compare this to this, they are quite a bit different. The A and B just had an I. And now C and D have a 4 minus I and a 2 plus I. So this has something plus or minus an I. This is where we have to use conjugates. Okay? So the conjugate, again, remember, is the same exact numbers and variables, or numbers and complex numbers, but the middle sign is different. And I have to do it on the top and the bottom. Okay? If I didn't do the opposite, things are not going to cancel. All right? So we're foiling in the top and the bottom. So I'll rewrite the top down here. So first outer inner last, I got 12 plus 3i plus 8i plus 2i squared. And then the bottom, okay, we'll just FOIL these out, then we'll come back and simplify them. The bottom, I have 16 plus 4i minus I squared. All right, now we look to simplify. So those are going to cancel out. And this I squared flips to a positive 1. Okay, so in the bottom, we just have 16 plus 1, which is 17. Numerator, so that I squared is going to flip that to a negative 2. So then you have 12 minus 2 is 10 on top. And then a 3i plus an 8i is 11i. All right, so now this one is not actually done because I have to have this standard form, okay? This does not look like that, right? This is just a plus bi, not a plus bi over something. So what we have to do is split this. We can simplify this a little bit more by splitting the fraction up. This is a common denominator on the bottom. So I split it to look like this. 10 over 17, that's the first fraction, plus 11 over 17i. And you can put the I up with the 11. That's fine. I like to put it out to the side like that, okay? So we got to write these like that. If there's a number in the denominator, you have to split it to look like that. All right, so next one. Think about this. Where do I need to look for a conjugate? So this is where I need to look. The conjugate is 2 minus I. And I have to do that in top and bottom. Okay? And we'll do the same thing that we did on the last one. So FOIL the top, FOIL the bottom, come back and simplify later. So 10 minus 5i plus 2i minus I squared. That's the numerator. Denominator, 4 minus 2i plus 2i minus I squared. So start to simplify. I squared flips to a negative 1. That gives me a positive 1 down here. And up here. Okay, so then we simplify on the bottom. So we have a 4 plus 1 on the bottom. That just gets us a 5. And in the numerator, I have a 10 plus a 1. That's 11. And a negative 5i plus 2i is a negative 3i. And then, just like this one, I have to finish it by splitting that. So this turns into 11 fifths minus 3 over 5i. Okay? So division takes a little bit of work, but remember the rule when you have an I squared, that cancels itself out. Okay? And then the last thing we're looking at here is how do we find powers of I. Okay, and this is where I said we need to remember this, and we need to remember I to the fourth is 1. Okay? So if we remember those, that should kind of take care of a lot of what we have. All right? So the trick to these, how many I to the fourths can I get out of here? Okay? I can get 3 I to the fourth. So I to the fourth, I said we can get 3 of those, right? So this is 12. So then I have how many of these left over? So 12 minus 15, or 15 minus 12, I have 3 of them left. Okay? And the reason I'm doing this, I to the fourth is just 1. So this is just 1. I don't really even need to care about these. Okay? Once I break it down using I to the fourth, then I break it down using I squared. So from here, how many I squareds do I have? Well, this turns into I squared times I, right? So I squared is a negative 1 times an I. So this just simplifies to a negative 1i, or a negative I. Okay? So I to the 15th is negative I. So recap how we do this. We look how many I to the fourths we can take out. We just get rid of them. Okay? We don't need them anymore. And then whatever we have left with, we simplify using I squareds. Okay? How many I to the fourths can we get out of this? So I to the fourth. How many of those can we take out? Well, 32 is the next number below 33 that comes out, so that's 8 of them, okay? And if I take 32 of those, I only have 1 left, okay? That's a 1. It's out of here. I to the first is just I, okay? We don't have to simplify that anymore. So this is our answer, okay? So again, look at this. How many I to the fourth can we take out of there? And if you can take nice groups like that, it makes it a lot easier. All right, a couple more. 120 is the power here. How many I to the fourth can I get out of there? Well, it looks like I could probably do 30 of them. All right, and that would take all 120 of those, okay? So if I have I to the fourth, which is just 1, to the 30th power, that's just a 1. So this simplifies nicely to a 1 because I'm using 30 groups of I to the fourth, okay? And we got another one of these. So I to the 42. Again, how many I to the fourth can I get out of there? Well, I can take 10 I to the fourth, and that would be 40 of those, right? So how many of those do I have left? I have 2 of them left. So this is just a 1. It's gone. And then we have I squared left over. And then we're going back to here. What does I squared equal? I squared is just a -1. So this simplifies to just a -1. Okay? So you now know how to multiply, divide, and use complex numbers and simplify when you're working with powers of I. Okay? So if you enjoyed the video, please leave me a like and subscribe. And thank you for watching.